В общем, у нас пока Álvaro подключается, я немножко расскажу про суть доклада. В общем-то, доклад достаточно интересный. Насколько я даже знаю, один из двух докладов, которые посвящены этой теме сегодня на сегодняшнем третьем дне нашего мероприятия, он посвящен такой теме, как логическое декодирование. То есть это такой шаг в сторону логической репликации в Postgres, который был предпринят в версии 9.4, он уже есть, он уже работает и, в общем-то, позволяет делать довольно интересные вещи, о которых сегодня будет рассказывать Álvaro, поэтому я рад передать ему микрофон. Давайте поприветствуем Álvaro.
Thank you. I basically agree with everything that he has said.
You shouldn't, because it was nothing good.
Then I still agree, because it will be fun. Well, hello, thank you very much for being here. Álvaro, as I believe I've been presented. I'm here to talk about a new feature that came to Postgres 9.4, which is called logical decoding, which I believe it is a great thing. And it has got some publicity and says that it's being explained a little bit what it does, but I think it's not enough. And that's why I'm here today, to explain why I think this is one of the greatest features, I would say, ever in Postgres. And before starting, I'd like to ask you an applause for those people that have been behind this feature, which some of them are present here, especially Andres. Yeah. Please stand up. Okay. I believe also Heikki has also been doing a lot of review, and some other people probably have left out here. Anyway, I believe this is a great feature, and you should be aware of it. And there's been some presentations already at some Postgres conferences talking about this feature. So before starting, and in case you want to leave now, I'm going to tell you about what is this presentation not going to be about. So I'm not going to be talking about logical replication. This is a feature that you may develop on top of logical decoding, and it's being developed. There's going to be VDR, UDR, and a set of replication solutions. Sloan is also building on top of logical decoding. So there's going to be a lot of replication solutions built on top of this technology. But I'm not going to be talking about that. That's been already presented. We're of course going to see the inner workings, but it's not the main topic. Neither the main topic of this talk is how to write an output plugin. We're going to see what an output plugin is, but basically it's a way of controlling what comes out of logical decoding. And there's also some material about that. It's not difficult stuff to do. What I want to talk about today, and so you can stay with me, is the new doors that this technology is opening. And this is the technology that basically it's going to allow you to integrate Postgres in more deep ways that have been possible before. To integrate with other systems, with other databases, with other applications, to basically extract all the data that has been coming into Postgres and put it somewhere else. So this is the main purpose of logical decoding, and this is what I want to reinforce today. So just before starting, a little bit about myself and my company. My company is called 8Kdata. Can anyone tell me why is the name, or what is the meaning of that name?
Page size.
Yeah. Exactly.
Default page size.
Default page size. Yeah, so we're a little bit geeky company. We try to perform research and development efforts based on the database space, especially Postgres, but not only exclusively Postgres. That means 99.99%. We offer professional services, consulting, training, support services on PostgreSQL. Back in Spain, we are also the founders of the PostgreSQL Spanish user group, which has been a very successful user group. It has been, since a long time, the third largest Postgres user group in the world, just after New York and San Francisco. Recently, it went down to the fourth position because of the Russian Postgres user group. Damn. It's okay. It's great to have that number of Postgres users in whatever user group. That's not the main point here. And of course, here are my coordinates. If you want to tweet, if you use Twitter, there's my Twitter handle and my LinkedIn account if you want to ask some questions later or whatever. So in one slide, not to bore you, what is logical decoding about? So basically, the idea of logical decoding is to extract the changes that happen to a database. In other words, any insert, delete, update command that you perform in the database, to get these changes out of the database in a format that is database independent. It doesn't, Postgres has had this feature for quite a long time called the WAL files, which are binary files, which are version dependent, and you need to parse them, and that's been done already. But it's tough to extract the changes from there. The idea here is to extract them in a format that it's independent of the database. It's a logical format. That's why it's called logical decoding. And we're going to be able also to control the output of this format. That's pretty cool. It is important to note that these changes are idempotent. This means that if you execute them again and again and again, you'll get the same result. So this is very important for reproducibility. If you are trying, and this is one of the goals of logical decoding, probably, I hope, or at least it is for me, to reply the state of the database at a different system. So if you need to do that, you need these changes to be idempotent. So for instance, if you have an update command that updates 10 rows, you'll get 10 commands. Not the original SQL command, say update I equal I plus 1, but you will say update I to value 8, update I to value 9, update I to value 10. Because those commands are idempotent. And they are ordered. They are in transaction order. Even if transactions are happening concurrently, they will commit at some given order. And the logical decoding will take place following that precise order. And the idea, as I was saying, is to reply the state of the database externally. So the idea is to take out this state to a different system. So we can create replication solutions. That's been the primary goal of logical decoding. But also to create, for example, materialized databases. In other words, to create a kind of a copy of this database into a different database, so we can switch technologies, for example. I'm not saying go from Postgres to something else, but the idea is that you can do it if you want to, for whatever reason. And of course, you can create third-party processing applications that would run on a live stream of data. This is basically what logical decoding is about. So let's see first how it works. So if we go to the documentation, which basically explains very clearly how it works, the idea of the definition of logical decoding is, I'm going to read this, process of extracting all persistent changes, persistent is important, to database tables into a coherent, easy to understand format which can be interpreted without detailed knowledge of the database internal state. So this is the idea. We don't need to understand how the database works to extract the changes, to get the changes from the database. As I was saying before, these changes are decoded row by row, even if they were produced by a single command. I was saying the update example is pretty easy to understand, because these changes need to be idempotent. And of course, this only applies to data that gets effectively flushed to disk, the WAL files. So temporary tables and log tables, they're not going to be decoded. The changes happening to those tables are not going to be decoded. Important note, as of today, there is no DDL decoding. So only changes to data are being decoded. So there's some ongoing efforts to get DDL decoded on next versions. It's going to be 9.0.
We have a lot of infrastructure in 9.5.
Yeah.
We can do it in this extension in 9.5.
Yeah, but it's not in core. I mean, yeah. So it's going there, getting there.
The other authors talking about that.
Yes, yes. There's, I believe it's the last session, one of the last sessions today.
Second to last.
No?
Second to last.
Oh, second to last. Okay. So the other Álvaro, it's doing another session precisely on this topic. So 1530. Okay. So most of the infrastructure is there in 9.5. There's nothing in 9.4. Most of that is the 9.5 with an extension. Thank you, Andres. You can do that probably in 9.5, and I guess that will make it to 9.6 in 4. So there's no DDL decoded. However, you'll get an empty transaction decoded if you have a transaction with only DDL statements. that is a signal that's been something there. And you can infer from there a lot of information, even if there's no DDL support, DDL change support. Yesterday there was someone asking me, I don't know, I can see here, well, whatever. Someone was asking me here yesterday, there's a way to basically pick the schema of the database and to change that schema picture with a graphic whenever something changes to the DDL. Well, you can even do that with 9.4 as of today, because if you get an empty transaction, if you get decoded, you get the output from the logical decoding process, and it's empty, you can infer that there has been some schema changes there. Doesn't mean that it has to be, but at least it's a sign that you can query the database again to see if there's been any changes. So it's a hackish way of kind of doing it. So anytime you receive something from the logical decoding stream, you may query whether there's been a DDL change. A little bit hackish.
Or if you see a lot of inserts into temporary table, that means that you had some alter statement of table.
Yeah, that's also true. Okay, what else? In order to do replication, logical decoding, of course, it's extracting all the information that has been changed in your database. That means that you're accessing all the data in the database, and this is potentially dangerous or potentially privacy concerns. So you need to have super user or replication parameters, permissions, in order to run logical decoding. And finally, logical decoding works on top of replication slots. So in Postgres, there are physical replication slots, which are used for physical replication in a way that controls the process in a finer grain that was before the appearance of physical replication slots, builds that code and creates logical replication slots. The idea of the replication slot, whether it's physical or logical, is that both the physical and logical replication works on top of the WAL files. They parse, they process in some way the WAL files, the external directory. And with the slots, you can control when the server is going to release those WAL files, when they're going to be able to be reused. So the idea of the slot is that you will only keep the minimum subset of WAL files necessary for doing the replication or the logical decoding that you need to do. This also has some problems as of today. We'll see later. So, what is the output? I've been saying that you extract the changes and you get them in a database independent format. But what format do we get the changes? So this is user control. So basically, the logical decoding process calls an output plugin, and this output plugin can decode the changes in whatever format the plugin wants. And you can write your own plugins, and this is pretty neat. It's not a difficult task to do, and there's one plugin available in the contrib distribution of Postgres, which is called test decoding. So these plugins are loaded dynamically, so they're like a shared library. So you can just place the binary on the library path, and it will get loaded dynamically as soon as you try to create a replication slot, a process we're going to see later on. And the output of these plugins can be text or binary. The current default, the included plugin decodes in text format. You can write a plugin which can decode in a binary format, and that's something that most people want to have, right, Anders?
But when we're using it.
Sure, it is. It could be neat too. As I was saying, there's a default plugin already included. How to connect to this stream of changes? There are basically two interfaces as of today to get these changes. One, let's say the easy one, is via SQL. So there are SQL functions. There are functions that you may call from SQL, which will allow you to get the changes to the database. So this is an easy method to start with, because you can just type the command and the function names plus the arguments, and you will get the changes. It has some limitations. First of all, you need to poll for the changes. So the database is not streaming the changes to you. You need to to check whether there's new changes happening to the database. You may look at them, you may consume them, but it's your responsibility to call these functions to get the changes. And there's also no possibility of exporting the, well, there's the possibility of getting a consistent view of the database if you also include these commands in a transaction and export a snapshot. But let me get back to this topic a little bit later too. So the SQL interface is primarily meant for testing, for debugging purposes, or for doing simple applications where you're going to be calling the database. If you really want to implement a solution on top of logical decoding, and this is the main purpose of this talk, probably the way to go is to use the replication interface. So to use the replication interface, you need to speak the replication protocol. This is one of the modes of the Postgres wire protocol. And with the use of this protocol, you basically have the full capabilities of logical decoding. You get the database streaming the changes to you in, let's say, more or less real time. So you don't need to poll for the database to get the changes. And you can also, and we will see how it can be done, when you create this slot, the replication slot from the replication interface, you also get a snapshot. The snapshot represents a consistent view of the database. And with this snapshot, you can also query the whole database in a state which is kind of frozen. So you can get all the data that was before the slot was created, and you replicate that, and then you can start streaming the changes. So you get the whole database, first the past, and then what's been changed from the moment you created the slot. Enough talk. Let's see how this really works to understand and see how it's easy to use. First of all, we need a couple of parameters to have logical replication work. The first one is to change the wall level. So we need to set the config parameter wall level to logical in order to be able to use logical decoding. There is some extra information written to the wall files when you use wall level logical, but it represents a negligible performance degradation. So it's not a big deal. You should probably use it. And also max replication slots, which is an integer number indicating the maximum number of replication slots. The replication slot is the window under which you can get the changes. So you can have several applications, several clients accessing the decoding streams, and those can go to different slots. So you can set here the number of slots. Also, if you're using the replication interface, you also need to set max wall centers. This is another integer parameter. It basically tells how many replication connections the system is going to be allowing. And also configure hva.conf to permit these replication connections if you haven't done so before. It is also probably interesting to check synchronous commit. It is usually set to on, but if you set it to off, the logical decoding process will not start until the commit has been effectively flushed to disk. So there can be a delay between the time the change is executed in the database and the time you get the changes. So you might also consider checking whether the synchronous commit is set to on. Sorry. So let's get to the workings. How is working? So SQL interface. Let's start with the easy one, or the simple one. It is very simple. So there are some functions like, first of all, we need to create a slot. As I was saying, the slot is the mean of communicating with the logical decoding process. And first of all, we need to create this slot. From the moment we create the slot, the logical decoding process will start. Any change to the database happening after we created the slot will be streamed or will be available for us to query. And it is also important, we'll see later, that we need to close this slot whenever we're not using it. So, create the slot, just call the function pg-create logical replication slot, and you have to pass a name. This name has to be unique across all replication slots in the database, whether they are logical or physical. And then the plugin you want to use for the decoding process. In this case, we're using the test decoding plugin, which is included in the country distribution of the database. So we call this function, we do perform the changes in the database, and then we can just use the some of the functions to get the changes from the database, like for example, pg logical slot get changes. So calling this function with the slot name, which is the slot name we said before, and then two parameters that can control how many changes we want to get from the slot. Let's try to do an example.
Do you need to execute the first statement only once?
Yes, it's just to create a slot. So you create the slot once, and then you can start getting the changes. I'm going to try to demo this, but I'm running on an operating system I'm definitely not using at all, and not familiar with, and I don't know if everything's installed here, but it's okay. Anyway, we'll give it a try. Demo effect. So let's first make this font size bigger. Oh. Is that enough?
Yeah.
Okay. So I believe there's a Postgres 9.4 around here. Can you hear me like this? Okay. So, no. There's another one here. Yes, this is Postgres 9.4. So first of all, we need to check whether the parameters are set. So, well, let's say I check that wall level is set. Oh, sorry. Wall level is set to I hate separates. Okay, so wall level is set to the correct value, and let's check that also max replication slots is also set to a non-zero number. Okay, so now we can start using replicate logical decoding if the test decoding module is installed. Let's check that. So first step, create the slot. So select pg, create logical replication slot. We give it a name. Name. A little bit lazy. And let's use the default plugin that's included in the country. That's decoding. And that is installed. Okay. I don't know where the error is.
Before the slot name.
Oh, okay.
Sort of, let's see. And
Did I say I hate Mac? Damn. So easy.
Oh, wow.
Okay. By the way, it's more convenient. I have shortcuts.
why do you have it?
I do have it because sometimes these connectors don't work well with it. That's the only reason I have it. And I never use it. That's why. Yeah. So this is a function returning tables. So it's probably more easy to check it like this. Select star from. So in this case, we get the output, which is the name of the slot, and the xlog position. This is the LSN. This is basically a position in the wall stream. This is interesting for you if you want to basically say where do you want to start replaying the logs. It's a physical representation of bytes in the wall files. So
Can you repeat the reading by switching the position on the beginning again and again?
what do you want?
Can you manually change the position to read again?
So the slot is created at time where it is created. However, when you start getting the changes, you can say, I want to read changes up to this point. You cannot go back, as far as I know. You can elaborate if you want to.
I think let's get on to a couple of slides. I think he's making the important point, and then we can go back to it because that makes more sense.
Okay.
Why the positions are different?
Oh, well, the positions are different because this is basically a new call. The new slot is created, and the slot is created at a different point in time, and there might be in a different position in the wall stream.
The SWOT work to swap the SWOT creation. Our audit.
I'm sorry.
Event of creation log to val.
I can comment this. It's just for every replication slot, there is a system catalog, and when we created the first slot, a new row was added to a system catalog, so the second one has higher position.
Actually, no, but.
Oops.
It's vacuum or something in the background that creates
Okay.
the records, because we can also create slots on the standby. That's why we can't use val to keep.
Okay, like that.
Kind of
Messing
like
things up.
that.
Okay.
Once you've created the transaction ID, that might be wrong.
So it doesn't. Yeah. It locks the standby snapshot if it's created on a master. It doesn't need val.
Okay. So we create the slot, and now we can start the streaming, or not streaming, because we're in the SQL interface. We can get the changes. So you can say select star from PG logical slot. Get changes. And here we say slot name, and then let's start from here. I'll explain later. Oh, yeah. Okay. So with this function call, we get the changes. There's nothing here because there hasn't been any change. So let's try to do some changes here.
Try out the slot. Let's see if there is anything. If anything happening.
So
we're wondering what was causing the values to change. The same for the other slot.
oh, okay. Well,
It's a log standby snapshot. It doesn't.
okay, so if we now, let's say, create a table. I'm not very original with table column names. And so we can see here that there's been some decoding process going on. So we get a transaction, as I was saying before, it's a kind of empty transaction because DDL code is not decoded as of today, as I was saying before. However, if I do an insert, and then get the changes again, now I can see that there's effectively some change decoded. So I got an insert. This output, this is created by the test decoding plugin. If you write your own plugin, you can get a different output. But we'll get at that later. As I was saying also, even if you perform a single insert command or a single update command, you may get several changes depending on these changes are basically row by row. Let's call it that way. So this is basically how it works with the SQL interface. Let's continue a little bit. Yeah. So getting back to the SQL interface, there are two types of functions to consult the changes. Get changes and peek changes. I've been using get, and this basically returns you the changes and also consumes these changes. By consuming, I mean that we're letting the server know that we have already got those changes, and the associated WAL files may be released at some point. Peek basically lets you see the changes, but do not consume the changes. So WAL files will be retained by the server. And there's also get and peek binary, which returns the same output, but in byte A format. So if you want to get it in binary format, whatever the output plugin is outputting, you may get that output also in binary. So if you call the function with binary, then the output is byte A. Also, there are output plugin options. And these are options to control the way, this is options that are, say, optional for the plugin. Plugins may implement different options at their will, and these options may be helpful for the plugin to control even further the formatting of the output. So in the case of the test decoding plugin, for example, we have two options available. Two options. So the first one is include timestamp, and if we use this option, we will get a timestamp of when the commit operation took place. And also we can include or exclude the IDs, the XIDs, the transaction identifiers of the transaction, which is by default set to on. This is by default set to off. let's just do a quick example of this. So the options are passed at the end of the function call. So to say here, timestamp. And then on, well, there are no changes. If I do another insert, then I get the time of the timestamp. So this is basically the output plugins have options. These options depend on the plugin, and they can be used to format the change. You can see here's the timestamp of the command.
What are those nulls?
Okay, that is the next point of the slide. But basically, these two nulls. The first one is the LSN position up to which you want to get the changes. So the second and third argument are used to control how much output do you want. If you want to say, let's decode only after until this position in the wall file, you set an LSN on the second argument. And the third argument is the number of entries. I only want to see n entries. However, I believe that is not exactly precise in some way. You can get more entries.
Yes, it
some
only
cases.
limits it on transaction boundaries because it wouldn't work well if you stopped it in the middle of the transaction.
Sure.
So if it detects it's above the limit, it will go to the end of the next transaction. Then
Yeah, the same happens with the LSN. If you say an LSN in the middle of a transaction, it will decode until the beginning of that transaction.
Did you always get the transactions from one transaction within another within another?
Yes.
They're not mixed.
No, never. Always transaction by transaction is a unit of decoding. You'll never get partial results, whatever you do. Okay, so
Transaction or physical commit. Yeah.
commit that has been flashed to disk.
Yeah.
So
Based on synchronous commit mode.
if synchronous commit is set to off, you will need to wait until it's flashed to disk to get decoded. If not, as soon as it's flashed to disk. If there are save points in a transaction, all those save points will be folded or unfolded, whatever is more correct, into the transaction itself. So it looks like all the changes happened on a single transaction, on a single unit of work. However, they are ordered in the way they were produced. And regarding the second and third arguments, this is basically the idea where you, I think he was asking, the position in the wall file up to which you want to decode and the number of entries up to which you want to decode. So here we have the full spectrum. We can do the get, we can do peek in text format, in byte A format, controlling the number of entries we may decode it, and so on, and some formatting options. It's a little bit important to talk about the slot lifecycle. So first of all, the slot, the idea of slots in Postgres is, I was saying at the beginning, to control the number of wall files that are kept by the server in your PostgreSQL database. And so as long as you are consuming the changes, Postgres will be releasing at some point the wall files where those changes belong to, and it will keep your server, say, healthy. Now, if you don't consume those changes at all, for example, if your client, which is consuming the logical decoding process, crashes, those changes are retained by the slot because Postgres knows that they have to be there to be consumed. So if you never consume them, your PGX log will start growing. And I guess most of us, probably all of you, know what happens if PGX log directory fills up, right? It's not a fun story. So this is, I believe, one of the only defects of, or not defect, something that needs to be improved in the future releases, that there's a way of controlling or dropping the slot if it's not used, but it's really up to you. It should be up to you at the end of the day. So first of all, if you're not consuming the slot, drop it. And when you're done with the slot, definitely drop it. Otherwise, you may end up with problems in your database, and it's something you don't want. Sorry?
So, maybe you can to automatically expire and use.
Yeah, that's what I'm trying to say. That as of today, that has to be controlled by the application. It's not, the database will do nothing to control that, even if it's unused for a long, long time. Or even if the client that created the slot got disconnected. Because you may use that slot from a different connection, so it makes some sense. However, I would definitely have a big applause to a solution that we in the database to control this kind of expiring slots or some ways of controlling this. Anyway, what else do we have? With the SQL interface, or without the SQL interface, doesn't matter. There are some catalog views that are very helpful to control the logical decoding process. These are the picture replication slots, and this is a view just with information about the replication slots, both physical and logical, so you can check how many slots that they are, which is the state in which they are. And also the pgstat replication, which will show you information about the slots and their activity over the replication interface. There were no information about the SQL interface here. Just to do just a quick show. This keyboard is so, the layout has changed. Well, whatever, doesn't matter. So here we can see that we have two slots created with the output plugin, the slot type, the database they belong to. Remind that the logical slots belongs to a single database, not a cluster. And on the view, the stat replication, there will be nothing right now because we're not using the replication interface yet. Let's go to that. I haven't done an example yet with updates or deletes, and this was made a little bit on purpose. The idea is that how do we control what output do we have from the output plugins when an operation is deleting data? In other words, a delete or an update. Well, all the inserts, you get all the new information, the new row information. However, the information you get out of an update or delete depends on a table parameter called replica identity. And this is a parameter you can set with alter table, and basically you can take these values. By default, unless you do anything else, it will only print about, let's say, the old data, the attributes, the columns that are present on the primary key, if there is a primary key on the table. You'll get all values, primary key values, and then the new values. And this is the default value. If you want to have all the old data, all the old row, full old row, you need to set this parameter to full. And in this case, you get all the values. You just set it to nothing, you get no values. And probably the smartest thing to do in many cases is to use to specify an index. If your table has an index, it has some restrictions, has to be null, has to be unique, has to be non-verbal, I don't know if something else, non-partial. Then you can say replica identity using index name, and then you will get as old values, all the attributes that are covered by this index. But let's do a quick example of this because it's easier to see. So we have a couple of values here. Let's do an update. Sorry. And now let's get the changes from the slot. Well, first of all, as I was saying before, here we have a single command, but we got 2 changes in the slot. One for each row, because these changes are meant to be idempotent. And now I'm getting only the new values. This is because replica identity was set by default. I didn't specify it otherwise. So if I change this, and then I perform the same operation as before, here I get the old values on the table. Then if I create a primary key on the table, by default I will get the primary key values that only when they are changed, by the way. I will get the primary key values as the old value. And if I create an index and I say replicate identity index, then I will get those values covered by the index as part of the old key. Let me remind you that the format this is printed is dependent on the output plugin. So the replica identity controls the information that is given to the plugin, not how the plugin is printing that information. The plugin may opt not to print this information and to do it differently. But it is that these values are going to be given to the output plugin.
Why is it connected to the index? It's not actually to the index. It's just the way of specifying the columns.
Yes.
Is there a reason for that?
Go for it, Teddy.
I mean, yeah, why not just list on school book?
Because that would be more complex. We already know whether primary keys change for hot and stuff. So that is just something we can do very easily.
Okay.
You can add a column list, but that will be much more expensive to check. So it makes sense to use primary key there.
Does changing replica identity to full gives more variety to its log?
Yes. Even if you set it to default or to an index, it won't, unless you change the primary key, you will, for an update, if you set it to an index, it won't log anything. But if you change the primary key, you will additionally include the old value because they're not in the val. And if you set it to full, every deletion and every update will have to have the old values.
Okay. So the other interface, the replication interface. So all we've seen so far is a SQL interface, and this is pretty good. Very simple to use. You've seen it. You can use it, and so you can get the changes. Now the real gem here is a replication interface. It's a little bit tougher to use because you need to speak the replication protocol. But other than that, it is probably the way to go to where I want to go. To develop external applications to extract the changes from Postgres. So you can either send the commands over the replication protocol, as I'm saying. There's a way to testing it with PSQL. With PSQL, you can also speak the replication protocol, and you can issue the commands. For example, create replication slots, slot name, logical, the plugin, and the options. This is knowledge of the replication protocol. There's also a command line built with Postgres 9.4, which is called pg receive logical, and it basically speaks the replication protocol and allows you to create slots over the replication protocol and start streaming. So this command is used to create the slot, and this command starts streaming and printing the information to the, in this case, standard output. Changes minus for a file name, and you'll get the changes to a file name and do whatever you want to. So we can leave some time later for questions, and I want to do that. I think I'm running a little bit out of time. So I want to jump to the most important part here, which is an open door. This is just a call for your imagination to develop new applications based on this feature. That's why I call it, it's a door to a new world of data exchange and integration for Postgres. Basically, what is this logical decoding used for? I know, or I believe that one of the primary intents of this was to enable logical replication. And this is really cool, because logical replication is replication that is independent of the database version, database architecture it's running on. And so there's several varieties. There is UDR, there's VDR, directional replication. There's, I believe Sloan is now working on retrofitting their software into using logical decoding, and some work on that. And of course, others may be using this. So it's a foundation for way simpler logical replication solutions. They no longer need trigger-based systems to work. Now, as I'm saying, this is much more. It is much more powerful. You can, for example, extract the data from Postgres and reproduce it in different systems. For example, you can take the data that has been changed into Postgres and integrate that into an analytics database. It's so beautiful.
Or into a memcache.
Or, yeah, I mean, into a memory database. or into a data processing stream, which is running on live data. Or, it's up to your imagination. That's why it's a really good technology, because it allows you to do many of the things that you cannot do easily before. And the point here is to create externally controlled data applications. So these are applications that are external to the database, is connected to the streaming replication interface, replicating from the changes that happen to the database, and then doing whatever you want to. It's also very interesting to integrate other systems, even PostgreSQL systems. Like, for example, if you have a shard environment, as I believe Zalando has, you can get all the changes from all the shards and then merge them all together into a single stream of changes. So even for performance reasons, you may be splitting all your data into different databases. At some point, you may merge them back into a single stream of changes and then process those changes in an integrated fashion. And indeed, the first step is to know which output plugins are available. So, as I was saying before, you can write your own output plugin. It's not a difficult task. They're very short C programs. And there are some plugins already created. There's the test decoding plugin, which is included in the contrib by default. It produces text output. It's not very easily parsable, but you can do that. And it's meant for testing, but it works well. There's the decoder raw plugin by Michael Packer, which basically decodes into SQL. So more or less gets back SQL commands. It could be used as a foundation for a logical replication solution. There's an interesting plugin to decode to protocol buffers, to the binary serialization format that Google uses. So you can consume, any application that consumes protocol buffers will be able to extract the changes easily from here. There's also another one called Wall2JSON that decodes the changes in a JSON format. It's also very interesting. And there's bottled water. This is one of my favorites. And it's uses...
This is our plugin. I hate you.
You forked that. Okay, I should have included your URL too. Yes, Zalando made heavy modifications to bottled water. Bottled water is an output plugin that, it's more than an output plugin. It's an output plugin and an external application. The output plugin extracts the changes in the average serialization format. And then there's an external application, as I've been saying all the time during this presentation, an external application that consumes these changes in the average format and injects them into Kafka. And of course, you can do your own plugin, which is something we are all waiting for. But let's go a little bit further than this. So output plugins are cool because you can extract the information in several formats. But what I really want to get at today is that this logical decoding, what it's basically doing is transforming or enabling Postgres to work as an event source. Event source in the sense of this pattern, named after Martin Fowler, who says that basically you take something as a source of events, and now you can propagate these events to many other layers of your applications and do whatever you want with them. So if you take, so what?
It's a mouse. Just touch this.
Yeah, your mouse. Okay, let me do this manually. Sorry about that. Okay, good. So, the idea of event sourcing is that you get all the changes to your database, and now you propagate them all, and you can do many things with them. You can, for example, perform real-time processing. You can feed these changes to an in-memory database, and then perform live queries and data which is being streamed to this database. You can materialize databases, and this is very common. By materialize, I mean you create another copy of the database, possibly to a different database with different characteristics. Typically analytics or specialized reporting databases. You can get the changes out of Postgres and then feed these changes to an analytic database like the soon-to-be open source QueryPlum database or CPTV, and then you can perform analytics queries on that data that you got from possibly several servers, several shards, and you're combining them into a single stream, the stream feeding to this kind of materialized database, and then you perform different types of queries there. or you can work with caches, as Valentin was saying before. So you can use this change stream to invalidate your cache in your application. Easy step too. No triggers. You can use it for auditing purposes, where you don't need to any longer write to your database the auditing information. You can, of course, do replication. That was the primary intent of this feature. You can distribute the changes via one for disaster recovery. So there are many, many options, many things that you can do with this technology. This is an example of an architecture suggested by the Bottle Border team. So I believe is a great example of what you can do with logical decoding. So imagine there's a web application, whatever kind of application, that it's writing some changes to the database. In the past, or without this kind of logical decoding, if you wanted to write several systems, like an index, like some monitoring system, like a cache, or a Hadoop, or whatever, you would need to have here in your web application code to write to the database, but also to write to the index, but also to write to the cache, but also to write to the Apache, to the Hadoop, or whatever. So your code here is becoming much more complicated. It is probably not transaction safe, and it is dependent. Each time you add a new system here, you need to deploy new code there, and this is a big problem. And then there's performance. However, now you can just write the changes directly to the database, then stream the changes via logical decoding to a broker like Kafka, for example, and then all the changes are here. Now you can connect any system you want directly to Kafka just by implementing the Kafka interface. And this web application does no longer need to know anything about how many clients of your data stream you're having. So you can add as many applications you want to, as long as this broker is able to hold this connection. So this is an architecture that is becoming very used in many high-performance environments and in very data-oriented architectures. This is basically the architecture that's powering LinkedIn, for example, right now. And you can do this. This arrow is the logical decoding. So, if you want to do an application, a system, to basically do this kind of, create this kind of architectures, and this is the main purpose of this talk, follow these very simple instructions and create these applications. The first one, implement the replication protocol. This is stuff. Then, no, it's not. Well, you can easily pick you. Then, open a replication connection. Logical start, create slot via the replication interface. This will return a snapshot. It is a way of reading a consistent snapshot of the database, consistent view of the database. Then, open a new connection. It can be a normal connection. You set the transaction snapshot to the snapshot that was returned by the replication interface, and now this connection has the consistent view of the database prior to creating the slot. From this point, you can read all the data of your database and event source it, and so you're basically exporting all the data before the slot was created. Once all the data has been exported, then you can enable copy both in the replication connection, so you can start getting the new changes after the slot was created. And then you should not forget to send feedback to the server via the replication protocol to get notified that you have consumed those changes. And that's it. I expect this kind of applications to be developed in the coming future that will, regardless of the output plugin, will be external applications that will be consuming this logical decoding information, processing it, filtering it, exporting several systems like Kafka or queues or whatever, and then enabling this world of new applications that will be connected to these brokers and consuming these changes from the database. As I was saying, to materialize new databases, to the real-time processing, to the stream processing, to connect to all the databases, to all the systems, whatever you want. So this is basically the idea. If you want to have some more information about logical decoding, of course, go to the PostgreSQL docs. There are some other presentations at some other Postgres conferences about logical decoding, probably more focused on writing output plugins and the replication stuff. And I'm open for questions.
can you return back to the slide with data change capture? Okay.
This one.
Well, actually, I watched several sessions by Martin Kleppmann, which is the creator of the bottled water, and this slide from his sessions.
Yes.
The question is, the first, how enabling logical decoding affects performance of Postgres, and on the previous slides you showed that we could specify the end position and batch size of data. Can we repeat the reading after we already executed get query? Like, for example, in Kafka, the consumer could specify offset from which it reads the data from Kafka log, and if something goes wrong, we could fix it and read the data from Kafka again. Could we do the same in PostgreSQL? Maybe we need to register another consumer or whatever.
Okay, kind of several questions there. So the first one is how it affects performance, and the answer is it's very low overhead on top of, you know, if you had basically wall level logical, that's a little bit of performance degradation, but it's very low. It's some performance, right, Andres?
It depends. If you only do inserts, it's very noticeable. It's less than 0.01%. And if you have like some load going on, but if you do lots of updates and you have the replica identity set to full, then it will increase the volume, because then we need to also
You're writing more to the wall files.
Yeah, so that depends on where your bottleneck is, but usually it won't be that much. And normally you don't constantly change primary keys. So if you don't need the replica identity full and you don't do change primary keys, it's very different. We did PG bench and the overhead was less than 2%.
Then regarding consuming the changes, if you're using SQL and you don't want to consume the changes because you want to read them again, then you should use peek rather than get. The functions that get the changes, they're the get functions and the peek changes.
But after
peek, you will get those changes again.
The position you execute with get,
for example. Yeah.
And like on the streaming protocol, when you just don't send a confirm message.
Yeah.
Or you send a confirm message with an old position. And everything up to the point which you confirmed can be received again. After the point you confirmed.
However,
for example, if you need to read all the data again, you just
if you need to read the data again, I guess you should create a new slot.
Or you cannot confirm it, but that will obviously lead to more data being stored, because the data has to come from somewhere.
Yeah, so I was saying, if you implement the replication interface, it is very important, as you see the last line, that you need to send the feedback to the server. This feedback is what tells the server that you have consumed that information.
By the way, from the bottled water, from what I remember is that they not start consuming from the current state of database, but they initially read the whole state of the database.
Yes.
Do they need for this logical decoding, or they just use some other mechanism for
So this is what I was saying here with the transaction snapshot. So in order to read the past state, so we have at the time of slot creation there are kind of two states: the past state and the changes after the slot was created. To read the last ones, the changes after the slot was created, you use logical decoding. To read the state before the slot was created, you via the replication interface you get a snapshot. It was the consistent view of the database. So you open a new connection here. It can be a normal connection. Then you set the transaction snapshot to the snapshot that was returned by the replication slot creation process via the replication interface. And then that transaction, you can, it's a read-only transaction. You should set to read-only transaction. Then you have a consistent view of the database. And with that, you can export that.
Then you get real-time stream.
And then you get the stream.
And you can create many transactions with the snapshot and hold it first.
Yeah. There was, I believe, a question there before.
I
A couple of questions. First, does a single uncommitted transaction block all the processing of the replication?
A committed transaction
Uncommitted.
will not block anything.
It's not flushed to disk, so we don't see.
So, an uncommitted transaction does not flush any wall file or any wall data to disk.
No,
What else? So does it or does not?
Well, there's no decoding process.
So who is buffering all the data that is in their wall file but it just not yet committed?
it's either stored in memory, or if there's too much, it's spilled to disk and then read out sequentially when the transaction is made.
So the spill to disk, is it configured somehow or is it using temp files? So what storage does it use so I can configure and
It depends
prepare for?
on the wall buffers.
What? Yeah, can
Separate buffer.
It's a fixed size that's configured somewhere, and it stores it in PG underscore repl slot, and then the name of the replication slot, and then there. And it stores 8 megabytes in memory, and then uses the disk.
Wonderful. And the second question, what is the performance? So as far as I understand, it is a single-threaded decoding, right? What is the expected performance to decode to, say, the null decoder? Just the processor call the function. So, million rows per second, 100 rows per second, 10 rows per second. What's the ballpark?
I could not make it to the bottleneck.
Disk bottleneck.
The database was too slow. It couldn't bottleneck on the decoding because we couldn't insert enough at the same time. So the only way to really make it a bottleneck is either to do expensive stuff in decoding, and then it can be a bottleneck. If you do a sleep 100 there, it will not finish ever. Or the other thing is if you have very large transactions and the disk becomes the bottleneck. That's the other part that can easily happen.
How will truncate table looks in logical replication? Truncate table command.
I honestly don't know.
It's DL in the end.
Truncate is transactional. You can make.
You can. But it's treated as other DDL, that is, you need to do something yourself. But what you can do is create a truncation trigger and do something in there.
Okay, I believe we have to end this session. Correct?
Yes, this picture looks really scary to you probably, but I would like to make a point that we have a prototype Python implementation for this Python interface. If you're interested, go check out on PsychoPG on GitHub. There is pull request open. Comment, try it, and for bottled water, there's also Python client that does all the stuff for you in a reliable way that uses this Python interface. So don't be scared by this. You don't have to use C, don't have to get into low-level details, detailed stuff. Try it.
Sure. Just wanted to say that if anyone has more questions, come back to me anytime. Thank you. Thank you.